Okay, this video is to take you through generations of programming languages. So if we remember that computers only understand binary, binary is machine code. So that's the only thing computers understand. So we call that first generation programming language, that machine code, that binary that computers understand, that's directly executable by the processor. So that is difficult to program and understand and debug because it's only written in ones and zeros. So that's first generation programming language, that machine code that's binary that the computer understands. Second generation, okay, is assembly code, those mnemonics, those three-letter mnemonics that represent certain things such as STA for store, INP for input. So it's easier to program in than first generation machine code, binary ones and zeros, but it's still quite difficult. One assembly language instruction, like INP for input, will translate to one machine code instruction. Now, assembly language, okay, needs to be translated into machine code. As we've established, computers only understand machine code, only understand binary. So that assembly code needs to be translated into machine code, and the translator used for that is an assembler. And assembly code is commonly used to program device drivers. And the third and final generation is third generation, which is what we program in as humans. So it's English words. So it's easier for us to understand. It's easier for us to find errors. It's easier for us to write. It's easier for us to debug because we write the word print. So one instruction translates to many machine code instructions. But again, computers can't understand third generation, just like they can't understand second generation. It needs translating. So we translate it using compilers and interpreters straight into machine code, straight into first generation machine code, ones and zeros, binary. So don't think it goes 3, 2, 1. It either goes second generation translated into first or third generation translated into first. So let's just recap the three types of translators. Assemblers translate assembly code into machine code, used when fast execution is required or limited. So that's an assembler, assembly code into machine code. Then you've got a choice of two when you translate in third generation, which we call source code because we are the source, into machine code. So compilers will compile it all in one go, translates the entire source code all in one go into that machine code, into that binary, and optimizes it. And this is often used at the very end of development when we know it's complete. It will create as error reports along with that object code, along with that machine code. So that's a compiler all in one go. An interpreter, which is kind of what happens when you press F5 in Python, okay, it translates and executes that source code line at a time, statement by statement. Okay, so it's checking for syntax errors, okay, and checking it's correct. And if it's incorrect, it stops at the point it can't go any further. So because it's executing line at a time in an interpreter, it'll stop when it gets to an error. So that's used in project development rather than at the end. So this video takes you through the three different generations of language and the three different types of translators. The final thing just to cover in this topic is what's called features of IDE, okay, integrated development environments. So features of Python essentially, because that's the integrated development environment you have learned. So what features does that give us? It gives you an editor, somewhere to create and write the code. It gives you a runtime environment. When you hit F5, a different window opens. It gives you a runtime environment, somewhere to run and see the code working. It gives you a translator, translates your source code into machine code. It does error checking for you. It stops when it gets to an error and highlights it to you, and sometimes gives you a little red error message and helps you. The color changing of the code, print in purple, and if statements in orange. And when you get the syntax right, okay, so if you write if name equals Mr. Liver colon, when you press return, it will automatically indent for you. So they are all features, the integrated development environment, of which Python is one, you get, okay. So they are a list of features there.